page 33 in your packet. Let's get reviewing for tomorrow. You're going to have 20 questions on that test, all worth 48 points. And yep, I'll be here today after school. If you want to get a big review session going, bring your packet in. What I did for you, as you can see here on the first half of that page 33, all the theorems that we've gone over. Okay, all the theorems. I'm going to ask you to write in something extra for me. Please be aware of auxiliary line problems, ones that you need to add in your own line, parallel line, because the one I gave you, there's no transversal for. Okay? So look back in your notes. I believe we did that day one. We also did a homework problem with it. Don't be surprised if one shows up tomorrow. Okay? Yep.
Like the lines of parallel, like if two lines of parallel and there's a transversal, doesn't need to go through just connect to one.
So if you have something like this and you just have this, that's a transversal, as long as they connect. But if I pull this on you, that's not going to count. Well, they connect, but it's not a line. Okay, so that's what I'm talking about, drawing in your own third line so that you end up having two transversals there, yes. Okay. Also, you'll see other theorems. Those other theorems are the ones we put on your index cards, and now I'm not going to allow the index cards to be used tomorrow. So make sure you know the wording pretty well, okay? Am I going to be lenient? Yes, but to a point if you write those in your index cards and you're just throwing out the words parallel and perpendicular and hoping it goes together. All right, kind of know them down pat, all right, because you will need them on a proof. I'll talk about that when I get to it. All right, so those other theorems you will need. Just a reminder of the three different ways to prove or write equations of a line: standard form, slope, intercept, and point slope. Do me a favor, please. Somewhere around that area on your packet, make sure you write in equations of vertical and horizontal lines. Okay. Make sure you can identify the equation of a horizontal line and the equation of a vertical line. We'll go over it one more time. I know we went over it during homework, but any vertical line will be the equation of a vertical line. X equals some number. And any horizontal line, y equals some number. No y-intercept. Okay? And you may also want to add in slopes of parallel and perpendicular lines. Okay? Slopes of parallel and perpendicular lines. Of a parallel line, what do you know about the slopes? Same. Equal. And perpendicular? Negative reciprocals. Okay? Then you guys see constructions. One of them will be on there tomorrow. Basic. I'm not going to do a square on you. I'm not going to do a quadrilateral on you. It's either going to be construct a pair of parallel lines or it's going to be construct a perpendicular line. Because I am just interested to see how many of you are going to prepare for that. Or are you going to just blow it off and try to freehand it tomorrow? It's just basic. I'm not getting crazy at all on that construction I chose to put on there. And then finally, 2 proofs, 5 points each. Guys, I am letting you know exactly what the proofs are. The first proof you'll have to do, in the proof statement, it will say, prove these 2 lines parallel. So while we're here, can we please list all the different types of angles formed by parallel lines? Here we go. Alternate interior. Corresponding. Alternate exterior. Same side interior. and same side exterior. Okay, let me go down this list right now. Alternate interior, what's the fact about them? Congruent, corresponding. Alternate exterior, same side interior, and same side exterior. I go over these with you because if you are going to prove lines parallel, you need one of these 5 to exist. All right? If it says prove AB parallel to CD, you need one of these 5 to exist, and whether they be congruent or supplementary. They need to be there. Hold 1 second. And then the second proof, you're going to have to use the index card facts. 1, 2, I don't know. All right, you'll have to use the index card theorems on that last proof. Go ahead, Logan.
You said you don't have the index cards with us.
Correct. So you're going to have to kind of know them down pat. The only one really that may cause an issue is the last one because it's a little longer. But before we do 2 proofs together, do you have any questions you want to ask about the test itself or just any of the topics? Yes, 2 proofs and that's it. 2 proofs, 1 construction, bunch of multiple choice, and then some short answer where you're going to have to set up an equation, maybe justify your work. And there are quite a few problems on slope, writing the equations of lines, what your homework was on out of the textbook. You ready to go ahead? What's up, Charlotte? Nope, no graphing. Can you have a scrap piece of graph paper if that helps you? Sure, but I'm not going to require you graph anything. Okay. Anything else? Good questions. All right, let's do a proof here. Turn to the next page.
Yes, sir.
Review proofs. There's a ton in there for you to try out. Answer keys are in the back. We're going to do a couple together. Also, at the top of that page, everyone see the textbook questions I'm suggesting for more and more practice. All the answers are in the back of your packet. I'm not checking anything. You guys are coming in and handing you the test like usual. All right, you can get number 1 set up. All right, here we go, guys. This is a 2-parter here, 2-part proof. First one, I need to prove BF and CE are parallel. So I just mentioned while we were going over the test, you got to find those special types of angles if you can. There is another way we could do this step, prove a parallel, if anybody sees it. All right, just based on those givens. BF perpendicular to AD, CE perpendicular to AD. So one way we could do this is, okay, I see perpendicular. What do perpendicular lines form? Right angles. So you could say, oh, I got right angles here and here, here and here. I know every right angle is congruent. Does anybody see any of the special types of angles that we listed here? Alternate interior, corresponding, alternate exterior, same side interior. Anybody see any of those angles with those right angles? I see corresponding. Whether it be these two right here or these two, they're corresponding. So they would be congruent because they're right angles. I could do it that way. Anybody know what type of angles are these two right angles inside? Same side interior, and two right angles add up to what? 180, making them supplementary. Another way we could do it. Did anybody just look at these two and not say anything about right angles? How I could get BF and CE parallel now because what they're perpendicular to. Or at least BF and CE are both perpendicular to the same line. And according to our other theorems we've learned this unit, they must be parallel. So just for time's sake, I'm going to get right to it and say that. Two lines perpendicular to the same line are parallel to each other. Got it. Continue the proof. It's not a new statement of reasons. Continue it now. Now that they're parallel, how can we get these two angles that I'm going to highlight up here, PFB, congruent to QCE? And remember, you already have parallel lines. Are those two angles any of these special angles? I think that's a struggle with some of you. That's where we are right now. That's a big struggle for some of you, is that you cannot identify if they're corresponding, if they're alternate interior, same side. All right, let me try to help you out here. Try to help you out. Are those two angles, are they part of parallel lines? Yeah, I have the parallel lines highlighted. And the other part of the angle, in this case CQ and PF, aren't they part of the same transversal? Yes. Okay, ready. So here's how we identify what type of angle they are. Are they inside or outside the parallel lines? Inside or outside? It's pretty obvious. They're outside. So it's got to be something with exterior. They're both outside. Here's the transversal. Are they on the same side or opposite sides? Opposite. So you basically have the name down already. What are they? Alternate exterior. And they are usually what? Congruent if the lines are parallel. Not usually, always. So this is going to be just one more step. PFB congruent to QCE. I am going to ask somebody, what would you write in your reasons column here now? 30, what can I write in my reasons column? Thank you. Hold on. Thank you for saying parallel lines. Imply. Nice job. Okay, so there's that one. And again, we could have gotten the lines parallel by saying the right angles are congruent and they were corresponding. All right, a lot of different ways. Anything on that one? All right, 3 is going to be a lot tougher. Number 3. So take a minute, set it up. Okay. You are proving A congruent to B. First thing, are A and B any of those special types of angles we wrote down? Because I've seen this too many times. People force it. Oh, I'm just going to call them same side, whatever, and hope it works. No, you're not. Look at A and angle B. Are either of them on parallel line CE? No. So they're not any special types of angles. Plus, hey, I've been trying to preach this all year long here. Do you know why I know this is not going to be a two-step proof? What have I always told you about your givens? Use all of them. You gotta. And if you just go to step 2 saying A congruent to B, you didn't even touch the bisecting part. So you know it can't be 2 steps, without a doubt. All right, so I did give you CE and AB are parallel. Can you find any special types of angles formed by those 2 parallel lines? Alternate interior, corresponding, alternate exterior. They have to be there. That's why I gave you the lines parallel. Can you find any of those angles up here in this diagram? And I'm not calling out a number. Naomi, go. Say that again. I heard A. C? C's not specific enough for me. And don't write that tomorrow, because C could be any of those 3 angles. DCE, there you go. I like that heck of a lot better. Angle A is congruent to angle DCE. Oh, I shouldn't have put congruent. I gave it away. Darn. What type of angles did Naomi just give me? Corresponding, yep. So parallel lines imply corresponding angles congruent. What 2 angles are we trying to prove congruent? A and B. I mentioned something about A, have not mentioned anything about B. I'm not done with the proof yet. Plus, I haven't even touched the bisector yet. No chance I'm done with the proof. I still need to say something about angle B, and I still need to use the whole bisecting thing. CC, next up. Okay, so now we're taking care of the bisector part, it looks like. So angle DCE is congruent to angle ECB. Got it. So those 2 angles up top here are now congruent. How did CC get it? She looked at the givens and said, that's what a bisector does. All right, our proof can go a couple different ways here. Remember, I'm trying to get A and B. I've yet to say anything about B. But I look at the 2 steps I just wrote, and I see DCE repeating itself. So I could go a couple ways here. Couple ways. What's up, Izzy? Where do we want to go? EC. Okay. All right. I'm good with that. ECB is ECB is congruent to angle B. Got it. I shouldn't have put congruent again. What type of angles did we just get? Alternate interior. I don't know how many of you took me seriously when I told you this, but what letter do you look for with alternate interior? Z. There's one up there. There it is. Yep. All right, now that's a great job. We talked about, we used all the givens. We used the lines were parallel. We used the bisector. Now we need to come up on our own by ourselves now how to connect all of this to get A congruent to B. I know you guys are thinking probably what in your head is going to connect all this. Substitution, which you're correct. How many congruent quantities have you written in your proof? 3. And you said you want to use substitution, which means you can only use how many of those 3 right now? 2. You can't use all 3 right now. So this is at least going to be a couple more steps. All right, which 2 can I use substitution on? Here you go. I'll take these for 2. Step 2 and step 3. A is congruent to DCE. DCE is also congruent to ECB. Anybody want to come up with a conclusion for me? Go ahead, Aaron. A is congruent to ECB. There's one substitution. All right, don't use those again. I'm done using those. Now how many congruent quantities are available? 2, steps 4 and 5. So look at steps 4 and 5 right now. ECB is equal to B. A is equal to ECB. I got 2 angles equal to ECB, so angle A is congruent to angle B. Also, I'll just mention this because I just had to chuckle a little bit grading your quizzes. It was correct. I just had to get a good laugh at it that 2 angles congruent to the same angle or congruent to each other. That's substitution. Okay, so, okay. 2 angles congruent to the same angle or equal to each other. That's good. It's substitution. Okay. All right. Right. So that was cute. Anything else up here? Okay, work right up to the bell, please. You got textbook questions you could try. All the proofs are in the back, done in the back as well. Take a look at those. Please do not focus all your attention on the proofs. It's 10 out of 48 points tomorrow. All right, make sure you can know parallel, perpendicular lines. Try out some of the textbook questions.